So let's see current electricity now, part 1. Part 1, current electricity. Current electricity. So first question is, in a potential circuit, cell of EMF. EMF is given, that is 1.5 volt. Gives a balance point charge, right, at a distance of 36 centimeter. Length of wire. If another cell that is given whose EMF is 2.5 volt. So we place the first cell, then the what is the length. So you have to find the D2 value. Right. It is asked in 2021. So see how they are related. So we will use the balance potential value. So it is given by E1 by E2 equal to L1 by L2. So E1 we know that is 1.5 volt, E2 that is 2.5 volt, and D1 we know that is 36. So you can easily find L2. So L2 will be nothing but it is 36 into 25 upon 15. So cancel with this by 5. So it will be 3, it is 5. And with this 3. So it will be 1, 2. So L2 will be 12 into 5. That is 60 centimeters. So L2 value is changed to 62. So please remember this relation between potential and length. So this is the balancing point. Done. Now see the question number 2nd. So you have to match the column 1 with column 2 with different quantities like drift velocity, electrical resistance. So I will give you the formula one by one. So please remember that one. So VD is called as drift velocity. Drift velocity. And so first formula is coming out to be force. Force is nothing but it is E. It is charge into electrostatics. Right? F is equal to nothing but E electron into E electric field. Right? Next formula is acceleration. So acceleration is given by force upon mass. So put here F value. So you will get F equal to EM upon small m. And as we know, V equal to U plus AT, right? So initial velocity is 0. So put here 0. So V will become, drift velocity will become A into T, right? So now put the value, fourth one. So VD will become A value put here. So it is nothing but it is put here A. So it is AE upon small m into T, right? So this is the fourth one. Now look at the fifth formula. As we know, R equal to rho L upon A. R is your resistance, and rho is your resistivity, and L is nothing but it is length. A is your area, cross-sectional area, right? So as we know now, V equal to IR from Ohm's law. So I will write here E is nothing but voltage upon length. This is the seventh formula. So put here. Now cross multiply, then you will get EL equal to V, right? So EL will become, V is nothing but it is IR, right? V is nothing but I into R. So R value put here. So it will be rho L upon A, right? So, and there is quantity we will using here, J. J is nothing but current upon area. So this is your current, this is your area. So put there J. So E will become length into length will cancel this and this part. So remaining is I into rho upon A. So I upon A is nothing but J into rho. So suppose this is your eighth equation, right? So finally we have got electric field equal to J into rho, right? So rho can be find out like E upon J, right? Now see the next part. Next part is nothing but it is relaxation period. So VD will become E M into T upon M, right? So current value we know that is electron into E into A into VD. So NEA VD value we have got right. Epsilon E tau upon M. We have just arranged it. So you will get I equal to nothing but NE square AE tau upon M. So arrange it, you will get NEA tau upon M. Tau is nothing but T. I V upon L. So M L upon NE square A tau. Tau means T is equal to V by I. So V by I is nothing but is your R. So right. So this is your R. So R is nothing but rho L upon A, right? So cancel that all quantities. So then you will get rho is equal to M upon NE square tau. So this is the rho value we are getting, right? And as we know, J equal to I upon A. So put here, so it will become NEA VD upon A. So then J will become NE VD, right? So B option is correct. So please write the whole explanation. Now see the question number third. Effective resistance of parallel connection that consist of four wire of equal length, equal area and same material. ठीक है? Four wires are there. Length is equal, area is equal, same material. Same material. So resistance value is given that is 0.25 ohm. R value. So what will be the effective resistance if they are connected in series? So when they are connected in, so four resistors, so connected in parallel, right? So diagram will be look like this. Four resistors. So add one more. So it will become four resistor, right? So they are of equal value. Resistance of each is given that is 0.25 ohm. So R equivalent is for the parallel will become 1 upon R plus 1 upon R four times, right? So it will be nothing upon 4 upon R. So R equivalent. So R equivalent will be equal to R upon 4. So it is given by 0.25 by 4. So this will be the value. So you can find the R equivalent value. So remove this point. So you'll get here 100, right? And we know, right, equivalent value. So erase this part. So you have to find R equal to R equivalent into 4, right? So R equivalent for the parallel is given that is 0.25. So it is 0.25 into 4. So it is coming out to be, after removing this point, you will get 4 here and this will get cancelled. So R is nothing but 1 ohm. Each resistor value is 1 ohm. Now they are connected in series. So series connection will be like this. So this is your parallel connection. This is your series. So it is R, 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 and each value is 1 ohm. So R equivalent will be 4R. So it is 4 into 1. So it will become 4 ohm. So in series, resistance value is more than in parallel, right? So please write it down. Now see the question number 4. A resistance wire connected in the left gap of the meter bridge is given 10 ohm. So R value is given 10 ohm. In the right gap in the which divides the bridge wire. So this is the bridge wire, this is the left part, right? This is the right part. So their value is given 3:2. 3:2 is given. If the length of the resistance wire is 1.5 meter, total length is 1.5 meter, right? Then the length of 1 ohm resistor will be. So length of 1 ohm, when R will become 1 ohm, so what will be the length of that? So C, for that, your structure will be look like in this. This is your P, this is your Q value, right? So this is your D point, this is your length 1. Suppose we are taking here C point. This is length 2 and connected with voltage. So we'll use that relation. So it is given by P by Q is equal to L1 by L2 relation we'll using. So P we don't know. Q value we know, that is 10, right? 10 ohm resistor. So that will be here 10. Length we know, length ratio 2 by 3 by 2. So your P will be equal to this and this will get cancelled by 5. So 3 into 5 is nothing but it is 15. So length will be 15. No, resistor value. So this is your resistance at P and resistance at Q, right? So this is your Q resistance we are knowing about it. Now we know the resistance formula R equal to nothing but it is rho L upon A. So it is R1 upon R2 is equal to L1 upon L2. So it is 15 upon 1 is equal to 1.5 upon L2. So L2 is coming out to be 0.1 meter. So this will get cancelled and here 10 we will getting, right? So L2 will be 0.1 meter. So it will be 10 centimeter. So write it down then.